section. Give the car air to breathe.
Nobody has anything loose in their pockets, right? Don't stand in front of the fan.
Steve, there's a warning. Check all their pockets in their trunk. I have something.
Anybody needs their hair parted?
Oh, shit.
Yeah, just to make sure we didn't steal any.
Blow your clothes off.
This is the best guy. Put the beat down for me. I turned this on once and it shot across the room. Like one of those swamp buggies. Your modern BMW has a whole bunch of computer logic in it, and we're now up to 3 megs of memory in the control unit. It only takes about, I don't know, 512K to run the engine. Seriously.
and
So what the rest of the functions are for is
way.
diagnostics and analysis. That's what it's for, right? If you go back to when I was a kid and I first started the business, which was 30 years ago in April, 1979, we had mechanical fuel injection, carburetors, things like that. And what we would do is we'd tune the engine to where it would make the most amount of power, then we'd take 10% out of it and sell it to people so that it wouldn't break. Okay? Because we didn't have the ability to monitor the engine when it was reaching near, whatever, any parameter that would hurt it. So we just had to back it way down. That's how the power chip business was originally born. If you go back to the 80s, BMW backed the power off 10%. Well, now you can advance the timing back 10% and make 10% more power. It wasn't rocket science. What's weird is the chip industry is still acting like it's 1985. Okay? They're still claiming the same kind of power gains we did in 1985. And 1985 was real because they actually backed the engines down 10%. On a modern engine, what they do is they measure the amount of pinging in the engine. They measure the temperature of the radiator and the block. They compare them to each other. They see what the heat exchanging capability is. They measure the air intake, air temperature. All this stuff has tables now. We go to these tables and we correct. These tables stack upon each other. It's hot outside. I'm going to take a little timing out. The radiator's not working as well because it's hot outside. I'm going to take a little more out. It's pinging a little bit. I'm going to take a little more out. Okay, and so what we do now is we tune the engine right up to the ragged edge and we let the computer fix all these little variables. Now when we advance the timing, nothing happens.
Right.
But the power chip industry still claims 25 horsepower. It's BS. Okay, you can put that on tape if you want. All right? There's a little bit of power there because BMW tries to smooth the torque curve with what they call a torque table or torque model. It takes little spikes and bumps out of it, so you can, so there's typically, 5, maybe 10 horsepower, and taking what BMW calls torque limits out of the map. But there isn't 25 horsepower like people are claiming. Okay, there just isn't. Okay, the engine's tuned to what's called mean best timing, MBT. Okay. And they're done by a bunch of engineers in a laboratory, much more sophisticated than this one, and they know what the hell they're doing. Okay? The brand new M5, the V10 that I pulled up in, has a system called ionization, and what it basically does is they run a voltage across the spark plug during the combustion process. So we light the air fuel off by the spark, and the fuel starts to burn. Now we run voltage across the plug gap. As the cylinder pressure builds, as the fuel burns, the resistance in the combustion chamber goes up, so it takes more current to bridge the spark plug gap. We measure the amount of current it takes to bridge the gap. We know how much pressure is inside the combustion chamber.
Sophisticated.
This is sophisticated stuff, guys, okay? All right? We measure the cylinder pressure on a per cycle, per cylinder basis. So every time it fires, we measure it. We advance the ignition timing, lean the fuel mixture until it pings. When it pings, it makes a shock wave, and that voltage, that current oscillates. And we can see the oscillation in the computer.
So it's constantly adjusting.
Constantly adjusting, okay? If you take a brand new V10, you advance the ignition timing 1 degree, and you put it on the dynamometer and you do 3 passes of a wide open throttle. On the 3rd pass, it puts the power back to where it was. That's how long it takes to figure it out. You take 1 degree timing out, do 3 more passes, it puts it back. Because it's basically already giving the engine the correct fuel measure and correct ignition timing on each cylinder, each one tuned individually to whatever's optimal. The only way you can improve the power output is if you say, I'm going to make that detonation threshold higher. All engines ping a little bit, you just can't hear it inside the car because the insulation and everything. So I say, okay, I'm going to allow a little bit higher level of detonation, which is a real risky thing to do because you might put a hole in a piston and break the engine. But the only way to get more power is to move that threshold up. So it advances the timing more before it says, I don't want to do that anymore. Okay, so all we're arguing about is how much detonation do we want? We put microphones on the engine and run them inside the car, and you can hear the detonation even while the knock sensor is working if you bolt the microphone to the engine. So anyway, the engines are very, very sophisticated. There's outrageous claims that they're naturally over 10, 20, 30 horsepower. Look, we started the power chip business back in the 80s. Okay, and then 2 or 3 years later, Conforti followed and a bunch of other people. Like there was a Porsche tuner on the East Coast, I can't remember his name now. I was one of the 2 first people in the German power chip business. We did it for Hondas and everything. We sold a lot of them. We sold millions of them over the years. I mean, it was a great product. But every year the engine management system gets more sophisticated, and the ability to get more out of it is less, with the exception of turbos. Like if you have a turbo, you can always turn the boost up, and the boost makes more power. Okay, so there's big power in turbo cars, 80, 100, 120 horsepower by turning the boost up on an engine. But a naturally aspirated motor, it's really, really tuned well. You can get really small incremental gains, 5 or 10 horsepower, and they're real. You can feel them. You can bump the rev up, take the speed governor off. Okay, but it isn't what it once was back in the 80s, and it isn't what people are claiming. Okay, it's not a realistic number. Okay, there's all talk on the forums about how Dyna's conservative with their number. No, we're not conservative. We're just realistic. I mean, the assumption there is, or the inference there is that we're somehow backing the engine power down because we're worried about it breaking or we're worried about it warranting it. No, we're just telling you what's really there, and we're not exaggerating the number. Look, these engines are so good with the knock sensors that I could run any ignition timing that I could want. The engine's not going to hurt itself. It's not going to cost me any more than $2. It's not like a turbo. Okay, it's just that there isn't anything there.
You're not
Just- there's nothing there,
increasing
okay?
efficiency at all.
Yeah.